Okay, question number 37 says Colin noticed that various combinations of nickels and dimes could add up to 65 cents. And it tells us to let x equal the number of nickels, y to equal the number of dimes. What is the domain where y is a function of x and the total value is 65 cents? Alright, a couple things before we start talking about this. We know that we have some number of nickels and some number of dimes and it has to equal 65 cents. Okay? And it also tells us that y is a function of x. Alright? Which means that x is sort of our independent variable here and y is our dependent. So y is depending on what the x number is. All right. And the reason that is important is because if they don't tell us that, we're not exactly sure which variable this domain is talking about. But if y is a function of x, domain is the set of numbers that you could plug in for the independent variable and actually make the equation work. Okay. The range would be, in this case, how many nickels or how many dimes you would have, the y values that you could actually plug in. So the domain deals with the independent variable. Most of the time that's going to be x, and since y is a function of x like it normally is, this is still going to work out. So the domain are all the x's. Domain is just the set, for those of you who don't remember, domain is the set of all possible x values. Okay. Now, in some problems that may be the t values, like if time is your independent variable, maybe it's the set of all possible time values, but it's going to be the independent variable, the number or the variable that normally would go on your x-axis. Okay, so that's what domain is. So we're looking for what x values can we plug into our equation that we're going to come up with, and it actually works out to solve the problem. So to figure out this equation, x is the number of nickels. So for every nickel, we have 5 cents worth of money. And for every dime, that's obviously worth 10 cents. And combined, those have to add up to give us 65 cents. All right. Now, obviously, in this case, practically speaking, x cannot be a negative number. You can't have a negative number of nickels. Okay. But you could start with 0 nickels. All right. But let's think about this before we assume that we start with 0. If I plug in 0 here, all right, that will become 0.5 or 0.05 times 0 plus 0.10 times y still, and that equals 0.65. And I didn't really have to write parentheses there, I just did anyway. But this is going to cancel out. 0.05 times 0 is just 0. So plus 0.10y equals 0.65. And so we get 0.10y equals 0.65. Now let's think about what this means. This is saying that some number of dimes has to add up to give me 65 cents. But you can't come up with 65 cents just using dimes. So that means I can't assume that I can start with 0 nickels. 0 nickels doesn't work, okay? So what I'm going to do is I'm actually going to cancel out 2 of these answers right away, because these 2 answers right here are saying that 0 nickels is part of the answer selection, all right? But remember, y is a function of x, so for every x that is part of our domain, we have to be able to find a y that goes with it, and you can't find an actual y that makes sense in this problem, okay, to go with an x of 0. So then we go to the next one. We start with 1. So 0.05 times 1 plus 0.10 times y equals 0.65. And as you're going to see as I work this problem out, this one's going to start to make more sense, because 1 nickel would be 5 cents. If I take away 5 cents from both sides to cancel that out, 0.05, then I'm left with 0.10y equals 0.60. Okay, so I'm trying to come up with 60 cents from just dimes. We can definitely do that. That would just be 6 dimes. Okay, so one combination would be 1 nickel and 6 dimes. So 1 is definitely part of our domain. All right, but that doesn't help us here because B and D also both start with 1. So we try, if you notice, B then goes to 2, whereas D skips to 3. So let's try 2, and if it works, then that means B is correct. If it doesn't, that means D has to be correct. So let's try this out. Let's imagine we have 2 nickels plus some number of dimes, and that has to be 65 cents. Now you may already be able to see this right away, but if you don't, I would just work this out. 2 nickels would be 10 cents, okay, plus some number of dimes, and that gives me 65 cents. Well, if we take away 10 cents here from both sides, these cancel, and I'm left with some number of dimes, y, times 10 cents, has to give me 55 cents. But we come up with that same problem. You can't get 55 cents out of just dimes, so there is no y that is actually possible for this context. All right, if you solved it, you would get 5.5, but you can't really have 5.5 dimes. So that means 2 will not work in this context, so B is also not an answer choice, so we go with D. Okay, and it should make sense because in order to get an odd number of change like 65 cents, you're going to have an odd number of nickels. Okay, because anytime you get an even number of nickels, like 2 here, that's going to turn that into some form of 10 cents. Or if you go to 4 nickels, that'll be 20 cents. Okay, and if you take 20 cents or 10 cents or 30 cents, you can't add dimes and get 65. You're going to need some odd number of nickels to work out here. Okay, and if we look, we go all the way up to 13 here. And if you do 13 nickels times 5 cents, that gives you 65 cents. So that would be paired with 0 dimes. So you can get 65 cents straight from nickels and with no dimes, but the opposite would not be true. You can't start with 0 nickels and get 65 cents out of just dimes. So our answer here would be